So good evening, everyone. I'm Dennis Peters. I'm the Associate Dean for Undergraduate Studies here at the Faculty of Engineering, and welcome to the Speaking of Engineering series tonight. Our Dean, Dr. Octavia Dobra, is unable to attend this evening, so she's asked me to lead this event and sends her regards. I'll start with the land acknowledgement. Please come in. We're just getting started. We acknowledge that the lands on which Memorial University's campuses are situated are the traditional territories of diverse Indigenous groups. And we acknowledge with respect the histories and cultures of the Beothuk, Mi'kmaq, Innu, and Inuit of this province. We encourage everyone to reflect on these lands from where you are located and the Indigenous peoples for whom these lands are traditional territory. Now, thank you for coming here this evening, particularly in this blustery evening. And supporting our faculty's Speaking of Engineering lecture series. Our lecture tonight is being broadcast by WebEx. I welcome the people online and is recorded so that it will be available afterwards. I'd like to extend special greetings to our guest speakers for this evening, Dr. Lourdes Peña-Castillo, close enough, and Dr. Stephen Charnock. I'll introduce those in a minute. Just take a moment to acquaint you with the emergency procedures. So we're not expecting any fire drills or any alarms. So if the alarm does sound, we have to evacuate out the doors at the back or at the front, through the lobby, out the front door, or down the stairs to your left and out that way. And the muster point is in lot 22 east of the business building. And also there are washrooms just outside to the left, out through the back doors here. So our Speaking of Engineering lecture series promotes engineering in our province and raises awareness of engineering related issues among students, the academic community, and the general public, which we feel is very important. This lecture series is an initiative of Memorial's Faculty of Engineering and Applied Science and the Professional Engineers and Geoscientists of Newfoundland and Labrador, also known as PEGNL. PEGNL is an invaluable asset to our program and to our graduates, and we are honored to get to partner with them to bring you this lecture series. We are grateful for their support. Tonight's lecture is about how Memorial's new Master of Applied Science in Software Engineering and Master of Artificial Intelligence programs will help meet Newfoundland and Labrador's growing demand across technology sectors. As co-chairs of these programs, which are jointly offered by the faculties of Science and Engineering and Applied Science, Drs. Peña-Castillo and Charnock will share their experience on why these fields are so important and how Memorial graduates will be trained to apply their skills in the real world. We will also hear the latest on Memorial's new Center for Artificial Intelligence and how the center will support both programs and its students. Dr. Lourdes Peña-Castillo is a professor in the departments of Computer Science and Biology in the Faculty of Science. Prior to joining Memorial, she obtained her PhD from the Otto von Guericke University in Germany and did a 3-year postdoc in the Banting and Best Department of Medical Research at the University of Toronto. Throughout her academic career, Dr. Peña-Castillo has developed and applied artificial intelligence, mostly machine learning, in various areas such as bioinformatics, games, and augmented virtuality. She also leads the Bioinformatics Lab at Memorial, which focuses on the application of machine learning-based methods to solve biological problems. Please join me in welcoming Dr. Peña-Castillo.
Okay. Hello, everyone. Thanks for being here in this first snowy night of the this winter. So what I'm going to do today? So I'm going to briefly talk about what is AI, why it's important, and why we need high qualified graduates in the area of AI. So let's start with what is artificial intelligence. Okay, artificial intelligence is not new. So it's not something that happened in the last 10 years. Actually, artificial intelligence has been around since the 1950s. The term was coined in the 1957. So even though it has been around for 70 years, there is a lot of confusion about what is AI. And there are lots of different definitions about AI. And also, the popular media has not helped with this confusion. There has been a lot of portraits in the media about AI, from the evil robot Terminator to the really nice lady in here in the operating system, right? So, but what is artificial intelligence? So the definition I like the most, and this is the one I am presenting to you, is that artificial intelligence are computer systems that can perform tasks that are considered to require intelligence. And I will point to that. I'm saying considered to require intelligence. I'm not saying that are intelligent of the being or the agent that is performing this task is intelligent. So for example, if we consider that to play checker, chess, backgammon, we need to be intelligent, then a computer system that are playing these games is going to be considered an artificial intelligence system. Now, if we consider that we need intelligence to understand language, for example, Alexa, turn off the lights, please, and it's going to work, then Alexa is an artificial intelligence system. However, there is a difference between performing tasks that we consider require intelligence to be intelligent. And that's an important distinction that I would like to emphasize. Okay, one of the main confusions that are currently going around is that machine learning is artificial intelligence or artificial intelligence is machine learning. That's not the case. Okay, so machine learning is a subfield of AI. There are many other areas in AI, like robotics, games, planning, natural language processing, computer vision, reasoning. I have not placed all the areas in this plot. There are just some of the examples. And machine learning right now is a very important area. Okay? And a lot of areas actually are intersecting. So we can have robots that use machine learning. And another kind of term that we use a lot nowadays is deep learning. So deep learning is actually a subset of machine learning methods. So if I was going to draw deep learning here, it will be inside this machine learning bubble. So why there is now the confusion between machine learning and artificial intelligence? Because a lot of the artificial intelligence systems that we are employing today are actually machine learning based. Okay, and why all the hype? So what is about artificial intelligence? So artificial intelligence history has been with a lot of ups and downs. So if you are old enough to be remembering what we have in the 1980s, you probably have heard about expert systems. In the 1980s, every industry wanted to have an expert system to do something for them, right? And then when these systems didn't deliver all the expectations or didn't fulfill all the expectations about them, then the kind of interest kind of died down and also funding declined. Well, now we are again in another up. And this is full because there have been massive amounts of data generated in a lot of areas, social media, healthcare, Internet of Things. So we have gathered a lot of data. And then also we have more computational power. So computers have more storage to do something with this massive amount of data and also a higher speed. Okay, so this has allowed that machine learning could be applied successfully in various sectors. Probably the best known is with image processing, image detection, and so on. Okay, so because of these successful commercial applications, then there has been investment in AI. Okay, so this graph is from the 2019 data, and it's basically showing the funding, the total funding in different AI areas in the world. So machine learning applications is there in the top with 28.5 billion. Then we have machine learning platforms, and then other areas of AI, like smart robots, and all the way to video recognition, okay? So, of course, if there is funding, then companies want to do it, right? And it's kind of the usual, so, oh, somebody's giving money if I say I am doing AI, so better I start doing AI. Well, that's the case, Okay, so many companies want to use AI. So this plot is for the 2017. Here, it was based on the response of 260 companies. And the question was, does your organization have any AI capabilities currently in production? Yellow, here, or 38%, say yes, it's an integral part of our operations. Then we have 42% saying yes, but still we need to work on it. So there is still a lot of room. Then blue, 50%, say not yes, but we plan to be there in 1 year. And finally, 5% of here, the gray, is saying not yet, but we plan to have it in 24 months, in 2 years. Okay, so we are seeing that there is interest. The companies want to apply AI. Okay, so what's the problem? Well, applying AI is not just that trivial, okay? There are lots of challenges, and there are also a lot of risk in not applying AI correctly, and that's what we have to be aware of. So for example, because of all this funding and interest, companies want to have AI. But sometimes AI systems are not the right tool to use, okay? So AI is not the answer for everything. So there has been some misuse of AI. Then if AI systems are not correctly implemented, evaluated, and so on, and monitored, they can have unintended biases that can have serious consequences. And we have already seen that in real life. And it's not like, poof, who cares? For example, there has been these cases of false identity. Like we have AI systems that will be identifying people, especially related with crime. And there have been already cases where innocent people have been arrested based on the false identification of an AI system. Okay? That's a problem. We also have biases, intrinsic biases. So for example, face detection software will work or will perform significantly worse with people that is not white. Okay, great. My camera doesn't recognize my face. Great. Okay, and there is also biases even in natural language processing. So I am not a native speaker, English native speaker, and when I call to some of these automate call centers that are not humans, are computers, it's like, I'm sorry, I cannot understand what you say. And it's like, wait, you could not train with people that have an accent? Most people that speak English will have an accent, come on, right? So that's really a problem. Then AI, if we don't design well, it might fail to cope with unusual circumstances. And why is that? Okay, I will give you an example. Probably 3 years ago, a Tesla car, so it was a driverless car, failed to stop when a human was walking in front of it with a stop sign. The car knew that if there was a stop sign on the side of the street, had to stop. If there was a human in front of the car, has to stop. Well, that human with a stop sign didn't know what to do, okay? So the driver have to intervene and stop. Well, we humans will say, the human plus the stop sign, stop, right? Well, AI systems, that's why I say that they can perform tasks that we consider require intelligence. They are not intelligent. They cannot comprehend and reason about the world. So that's a problem that we have to understand when we are employing and developing these systems. Also, in some sectors, AI has to be transparent, especially in the healthcare. So we will not trust somebody that say, you have this disease without actually an explanation of why is that diagnostic, right? We need to know how and why this decision. Now, AI might be abused. Basically, this will be used for an unintended purpose. Classical example, we have now deep learning system that can generate image and that can generate videos. Surprise, they are being used to create fake news. Okay. And finally, they need to be extensively evaluated so that we are sure that all of this is not going to happen and monitored after deployment. Okay, so if applying AI is not trivial, what we need? We need high qualified personnel able to do AI correctly. And that's where it comes the Master of Artificial Intelligence, one of the new programs here at Memorial University, or MAI. So the Master of Artificial Intelligence is jointly offered by the Department of Computer Science in the Faculty of Science and the Department of Electrical and Computer Engineering in the Faculty of Engineering. So what is the goal that we have, or what we envision for the students that take this program and graduate from this program? So we are hopeful that these graduates will have a deep understanding of AI methods and techniques, strong skills to design, develop, evaluate, implement, and maintain AI systems. And also we want to have graduates that have problem solving and analytical skills to identify which AI technique, if any, they should also say AI should not be applied here, but basically identify the best AI technique or the most suitable AI technique to perform a given task. And also be able to optimize this AI system to perform the best that could be achieved. And also, this is in the end of the list what is really important, and we are really trying to make emphasis of this. We want our graduates to be aware of the AI ethical issues. Okay, so we want them to know that AI has to be transparent, fair, and with no biases. And I will not go through more details about the program, but I will just point out about where you can get more information about this program. So the Master of Artificial Intelligence, we have in the website, we have a full description of what is this Masters. So the program description, the career options, and the program of study. So this is planned to be a 4-term course-based master's program. So the program of study has to be followed pretty close so that the graduate will graduate in 4 terms. We have the admission requirements, fee and expense, and application process. And I will be happy to answer any question of the people here in the audience, personally or present, and any people that is watching online in our question and answer session, which is going to be after Steve's presentation. Okay, thank you, everyone.
Thank you very much for that, Lourdes. I get my notes so I can tell you a little bit about Steve. Dr. Stephen Sharnock is an associate professor of biomedical engineering in the Department of Electrical and Computer Engineering, and he is jointly appointed to the Faculty of Engineering and Applied Science and the Faculty of Medicine, and is director of the Center for Artificial Intelligence at Memorial University. Dr. Sharnock obtained his PhD in biomedical engineering from the University of Toronto, where he focused on human motion and activity detection using computer vision and machine learning. He has extensive experience developing technologies for vulnerable populations, implementing a holistic, user-centered design philosophy centered on identifying user needs and evaluating health outcomes. Dr. Sharnock's research is inherently interdisciplinary, lying at the intersection of engineering, computer science, medicine, gerontology, rehabilitation, psychology, and sociology. Specifically, he seeks to develop relevant, accessible, acceptable, and adoptable patient-oriented technological interventions based on autonomously tracking human motion using computer vision. Further, he emphasizes the evaluation of technology efficacy by connecting academic research with healthcare providers and patients in a real-world context. His technical focus is on machine learning, deep learning, and computer vision. Please join me in welcoming Dr. Sharnock.
Thank you, Dr. Peters. Is the audio okay? We're good to go? Okay, thanks everybody for coming, especially, I shouldn't say especially, but those who came in person. I hope you were already here and you didn't necessarily brave the weather to make this trip. I hope so. I was debating myself whether to make the trip in, just kidding. Anyways, thank you very much for the kind intro. A tip to anybody out there, when you're writing a bio or when you're asked to provide a bio, envision that somebody might read it. I would have probably written half as much had I thought about it. Also nice to follow up my colleague for the discussion on the Master of AI. We built the Master of AI and the Master of Applied Science and Software Engineering together as a joint proposal. So you'll probably get a bit of a feeling that this is almost a similar presentation, although you can maybe swap out AI for software engineering. But really, I'm going to try to do a little bit more discussion around what software engineering is, and again, to present a little bit of information on why we think that a Master's of Software Engineering is important. So I am joint appointed between two faculties, Faculty of Medicine and Faculty of Engineering and Applied Science, and I am the very new director for the Center for Artificial Intelligence. So I'm learning as much about it now as I'm going to try to share with everybody here today, and it's a relatively new movement and a new research center. So with that in mind, I'll get started. Just get a clock. I have a habit of talking a little bit too much sometimes. So software. This idea of software is the same as the discussion on AI. Software and software development have a very long history. It's not as though software engineering or the concept of software engineering has just emerged in the last couple of years. In fact, I think that the thing that has changed in the last couple of years is the designation or the title of software engineer. So software development, programmers, coders, computer scientists, you'll hear all these words and these names and these job descriptions in reference to the idea of software and software development. And we can kind of split hairs and we can spend a lot of time here trying to operationalize and define what they all mean. But really, it doesn't particularly matter. Software developers, for example, are often coined as being people who develop, who are goal-oriented and who work with a customer, for example, or who work on a problem with the intention of solving a goal, whereas a programmer or a coder might be qualified or quantified as being a person who is more specific to actually smashing the keyboard, punching in keys, writing code, and developing solutions to a specific task. But the idea of a software engineer becomes a little bit sticky because of that title of engineer. And I think that this is an interesting thing for the Faculty of Engineering and Applied Science specifically because the title engineer is regulated in Canada. And in many countries, the title is regulated. So the discussion about software engineering or a software engineer has really come to the forefront in recent years. And I'll explain a little bit why on the next couple of slides. But basically, the idea of being an engineer is specifically that you practice engineering. And most engineers who call themselves engineers should be governed or regulated by their provincial authority. So the practice of engineering is quite complex: planning, designing, composing, evaluating, doing all of these things. But the key to that is that it involves the application of engineering principles. And that implies that somebody has explained to an engineer what engineering principles are, presumably through formal education. So lots of universities have engineering programs, and we pump out engineers by the tens to hundreds every year out of Memorial and across Canada in the thousands. So the application of engineering principles makes the discussion of software engineering salient. But also, not just engineering principles, but that are impacting or safeguarding life, impacting health, property, economic interests, the public welfare or the environment. Or sorry, the public welfare, excuse me, or the environment. So engineers are perceived to be people who are using engineering principles to impact people in some meaningful way. And this is where it gets a little bit sticky and why I'm going to try to present a good case for why we've presented the Masters of Applied Science and Software Engineering. So this idea of software engineering admittedly overlaps with lots of other fields related to software development, software programming, coding, computer science. Our colleagues in computer science are quite close with us because we have a lot of synergies. I would consider myself an AI researcher. I would consider myself a machine learning researcher. I would consider myself to be a computer vision researcher. I would also consider myself to be a software engineer and a computer engineer. So it depends on how we kind of cut the cake and which sort of piece of research we're doing. And I think that you would probably feel the same way as well, depending on what you're working on. So Engineers Canada has defined two aspects that define a software engineer. Basically, if the work of the software engineer concerns public interest, and I think Dr. Peters had a big role in this paper with Engineers Canada as well, their position piece. He chaired the committee. The work of a software engineer has to concern the public interest. So again, life, health, property, economics, public welfare, or the environment, and require the application of these engineering principles. Now, interestingly, I talk a lot and I lean a lot on Engineers Canada and some of this sort of background work, but it's really important to mention that Engineers Canada and graduate work and graduate degrees in engineering do not get accredited. They're not regulated by most national or international bodies. So the discussion here is really about understanding what the expectation is at the undergraduate degree, so that when we designed our graduate program, we were taking those skills, those key components, and building on them so that we could put forward the best graduates who would be at the bleeding edge and the leaders in their fields relative to other software engineers who would have an undergraduate degree, for example. So software engineering, the business case to it. Academically, it's relatively straightforward to take a look at software engineering programs across Canada and around the world to see what's offered, to understand what's happening, but there should be a business case as well. If we're going to be offering degrees and we're going to be telling graduate students, for example, come to our university, take our programs, we're going to give you advanced skills, there should be some sort of long-term or even relatively short-term impact associated with that. So what we see is crazy amounts of technology emerging. Technology that's definitely touching our lives, not just a dot matrix printer that's printing something out and it didn't print very well and you can reprint it, you can take a look at it. But autonomous vehicles, discussions about autonomous vehicles, making terrible and tragic decisions because of perhaps a lack of rigor or a lack of understanding or many, many complex reasons to why these things can happen. Even simply flying, the technology in airplanes and seeing what one sensor can do for the Boeing 737s that crashed because they were only equipped with one sensor that failed, and the software implications associated with that, satellites, networking, communication, technology and healthcare, banking, all of these things have very, very real and material impacts on humans. And so, based on the argument I put forward, or based on the definitions earlier, I would make a strong argument that software engineering as a discipline is really evolving and is becoming more and more important. Software engineers are not just programmers. Software engineers may program, but software engineers, especially at the graduate level, are envisioned in our minds anyways as being leaders of software-related endeavors, whether it be in business or in private industry or in public sector work. Software engineering degrees, as a result, we've seen, and I'll show you a little bit of the results of our sort of network analysis, our analysis of sort of the academic landscape. They become a top priority for many major universities. Lots and lots of new software engineering programs, both at the undergraduate and graduate level, have started to emerge. There's continuing demand right now for software engineering. Local companies like Verifin, TechNL, and consortiums like TechNL, and a lot of the new startups that are coming out of our various incubators and associated with our Memorial Center for Entrepreneurship are all asking for more and more highly skilled people who are ready to work right out of a degree. Many of us, when I was going through university, my undergrad a year ago, 2 years ago, I'm not going to say how old I was, but when I was going through undergrad, we used to talk about how it didn't really matter, that we were learning the foundations for work and that we would go to an employer and the employer would train us on what we needed to do. I don't know if that's a legacy opinion or not, but employers are now moving very, very fast, especially in software-related fields, and want people who are ready to work with basic known skills right off the bat. So this applies to both the AI and to the software engineering program. We're looking to develop graduate students who are ready to enter the workforce right away. Within software engineering specifically, although this does apply to AI as well, we're expecting accelerated growth. Not just we as in Memorial University, but Canada as a country are expecting more and more pressure to have highly trained people in AI and software engineering. So in Canada, according to the Government of Canada, for a relatively recent poll in 2019, they're expecting that they will need 27,500 new jobs specifically in software engineering within the next 10 years, but they're only going to be 24,000 people. Those numbers are relatively small, but this is a very, very pure and specific requirement for software engineers. That's 3,500 jobs in advanced software engineering in the next few years that people could immediately enter into. So these are jobs that are already out there, that are going to be out there, that people need to fill. Projections for Newfoundland and Labrador, unfortunately, our province hasn't been overly proactive in trying to understand what some of these tech needs are as a provincial government anyways, but lots of the consortiums like TechNL, for example, are doing some work to show these numbers. But predictions across Atlantic Canada are particularly high. Atlantic Canada is emerging and Newfoundland is emerging as a technology hub for really, really advanced work. Wages for software engineers are also really high, averaging around $100,000 a year for semi-entry level positions. This is a really highly skilled profession. With a highly skilled profession suggests that we have room to not only train people to make sure that they're at the forefront of that, but to also start to understand and standardize how we can sort of discuss the skills associated with that profession. Maybe toward regulation, but I think at a minimum, as our commitment as an institution for education to be able to tell people who are looking for these highly skilled people what it is that they're going to get if they hire a software engineer. So we did a quick survey. It wasn't really that quick. It took weeks and weeks and weeks, and I think you and I were quite stressed about doing this work. But in the end, we looked at 96 Canadian universities, all of the top universities across Canada, comparable universities in size to Memorial, big universities like University of Toronto, UBC, McGill, small universities like Concordia and Thunder Bay and whatnot, 96 universities. 27 of them are offering undergraduate degrees in software engineering. Now remember, we're not talking about undergraduate in software engineering, but those 27 undergraduate degrees are what we use to help build the structure for our program, so that we could look at what was being offered within those degrees, what we were currently offering, what we thought we had expertise in, to leverage that. Those 27 programs all started within the last 7 years. 10 master's degrees in software engineering or related areas. This is actually 1 year old now. I think there are 12. I should have probably updated the slides since I made them this morning, but details. 10 master's degrees currently, I can confirm 10 master's degrees are currently being offered. Those were in the last 3 to 5 years across Canada. So these are relatively new programs. If we take a look, 3 of them are in Alberta, 1 is in BC, 1 in New Brunswick, 4 in Ontario, 2 in Quebec. The only one within Atlantic Canada is at St. Mary's. It's a specific master's degree in software engineering with a focus on quality, reliability, and maintainability. We'll see that that's a very specific subset of what's considered software engineering. So what does that mean? Very timely for Memorial University. Memorial could, with the strong establishment of this program, establish itself as one of the leaders in software engineering graduate degrees, not just in Atlantic Canada, but across all of Canada. So the time is right for us to do this. So when we put together this proposal, we were specifically looking at students who already had a degree in computer science, computer engineering, or software engineering, because our intention is not to train undergraduates. Our intention is to train existing undergraduates who have degrees in these related fields to become the best and the top of their field with advanced skills. We designed it as a four-term course-based program, the same as the Masters in AI program, because the course-based programs put a lot less emphasis on research and on developing cutting-edge modern techniques and learning scientific method, for example, as a graduate student, and more about training skills, advanced skills at an advanced level. So again, we could impact the workforce directly, and it was jointly offered, of course, by the faculties of Science and Engineering and Applied Science. How am I doing for time? Oh, pretty good. Okay. So our idea here was really that the graduates of this program would have advanced knowledge and understanding. And I highlight advanced because this is the difference. We're not just trying to develop base level knowledge and understanding. We're not teaching students what programming means and how to use a keyboard and things like that, not to be patronizing, but it's really about advanced skills. Taking things that they're already interested in, taking things that graduate students are good at, and giving them that step up so that they can directly enter the workforce in a good position and make an impact right away. And then also, if we think about it from the other side, to be able to satisfy that need that industry has for people who are ready to do these things. So be ready to work. Positions in software engineering, generally speaking, private and public sectors. We're targeting Newfoundland and Labrador specifically. Of course, it's our home province. And when I talk very briefly about the funding model associated with the Center for AI, you'll see that it's a partnership between the federal, provincial governments and the Memorial University. So really, with both of these programs, we're aiming to directly fill a market need. A lot of words on here. This is really up there for the sake of completeness for anybody who might want to go back and take a look at this. But the idea here is, again, leveraging the Engineers Canada syllabus or curriculum. Compulsory examinations, looking at the 8 different fields that are required within software engineering to be considered a software engineering program. We're trying to touch on all of those to develop those skills, either through our core components or through some of our elective components. And then lots of optional examinations. This again touches on that same discussion about AI. Software engineering is very, very broad. And how you characterize it and how you define it can be very flexible. We're trying to maintain flexibility by offering some of those core components that will give an employer that guaranteed understanding of what is coming their way, but also to allow students to follow their own passions and their own interests, things that they're interested in, because any graduate degree, if there are any graduate students here, know that it's a bit of a slug at times and you want to enjoy what you're working on. So our program, very quickly, I just want to highlight here, there are 7 core courses in the software engineering stream. I don't particularly want to focus too much on what the core courses are. I want to highlight here that the red ones are offered through computer science, the bolded black courses are ones that we had to create, and the other 3 are engineering programs. So here I'm showing that we're not only leveraging existing expertise, but we have a beautiful synergy between the 2 faculties and the 2 departments within the 2 faculties. And that also we had an opportunity with these 2 new programs to bring in some new faculty, to develop some new courses and to expand the current capacity and capabilities of our institution. Lots and lots of elective courses, same thing again. Tons of them are here. These are all better to view on the webpage. I should have probably followed your lead and just put a link to the website. Again, just to show the diversity. So courses that are already offered in engineering, courses that are partner offered through computer science, and courses that are relatively new and under development that we're bringing to the university as part of our capacity building and the expansion that these programs have brought to our faculties. The nice thing about this diversity is, again, that idea that you can choose your path. It's almost like a choose your own adventure, because graduate school, again, we're trying to kind of provide a standardized advanced education, but also to allow people to explore their own interests. So with that in mind, I'm going to switch gears very, very briefly to the Center for Artificial Intelligence. I am now the director of the Center for Artificial Intelligence. Only happened maybe a week or 2 ago, so I'm still trying to figure out what that means. But I've been part of the instatement of the Center for Artificial Intelligence since conception, so I have a strong understanding of what it is, just maybe not necessarily yet what my role is in this center. So the Center for Artificial Intelligence, I think, notionally has 2 major roles. The first one is to support the offering of the Masters of Applied Science in Software Engineering, the Masters of Artificial Intelligence, and the Masters of Data Science. The 3 of them are supposed to be supported by this center. The reason for that is all 3 of these programs require special facilities, special computing, and the idea is, with them being these course-based master's programs, that there's also a collaborative portion of it, to be able to build a network and create relationships between partnering companies and partnering faculties. And then I guess the other half of the role for the center is going to be related to research and service and collaboration outside of the program delivery of those 3 programs. So the center is really about this partnership idea. We have industry who is begging for highly trained people. It's the whole motivation behind the launch of these programs. Our province has great entrepreneurial ecosystem. It's growing faster and faster. I've been here now for 10 years, and I've seen just a remarkable change in the tech landscape of this province. So specifically, the Center for Artificial Intelligence, as the name implies, was specifically about supporting artificial intelligence, but also other computer-related courses, software engineering, data science, and perhaps some other things as we make our way forward. It's a collaborative space. It involves researchers, it involves students, it involves industry, it involves teaching. All kinds of amazing things hopefully are going to happen there. It's going to be located on the 5th floor of the core science building, closest to the university center, right above electrical and computer engineering, if anybody knows where that is, over in the new building. So it was funded. I'm sorry I don't have my speaker's notes, so I'm going to go by memory on what this was, but it was funded with roughly $2 million. $1 million was from the federal government. The mechanism that they provided that money was through a COA. And then approximately 500,000, I think closer to 400,000, 432,000 from the provincial government, and almost 500,000 from Memorial University. Lots of money was put into this. Commitments for faculty hires, commitments for space, commitments for partnerships from our industry around us. So a couple quotes from Minister O'Regan: Newfoundland and Labrador's tech sector punches above its weight. We're a small province doing amazing things. With the support of Memorial University, we're thriving. A new center for AI will help us take on the world. This is the vision of our federal government, our Minister of Labor, Federal Minister of Labor. Premier Andrew Furey also says collaboration across all of these different groups is really, really important. Supporting Memorial University's new master's programs builds on that, specifically talking about the AI and software engineering program. Builds on that spirit of collaboration, contributes to the development of a highly educated and skilled workforce for this expanding industry. Our federal government is seeing it. Our university is always willing, I think, to support these initiatives, and our provincial government is backing us up as well for this new research center. So over here, I've included a picture because sadly the space is not quite ready. It should be ready hopefully within the next 6 months. There's not a lot to see other than a lot of construction right now. So the pictures don't do justice, but this was the official unveiling. I'm not necessarily the most politically minded of people, but I thought it was interesting to see our federal minister provincial member, an MHA, Dr. Timmins, the president of our university, and then our TechNL CEO, Florian, who used to be the MCE director until relatively recently. So this is a really, really beautiful partnership of federal, provincial, institutional, and industrial groups. Lots of numbers up here, but basically what it is about 1,500 square feet, so a relatively large, flexible space that's meant to be diverse enough to support various modes of teaching, collaboration, research, and advanced education. I guess the major take home from this also is that we're expecting by mid-March of 2023 for it to be fully constructed and ready to go, and then hopefully taking effect as of April of next year. So the last thing I will mention, I think that that's the end of my presentation, but the last thing I will mention is that the two programs, the Masters of Artificial Intelligence and Software Engineering, both launched last September, so 2 months ago. So we're now partway through the first term of those two programs. Between the two of them, we had over 180 applicants for what we were estimating would be 15 seats in each program. So we had really, really good interest both locally and internationally in the program. The launch of the programs was relatively late given the sort of way that the cycle works for admission. So we over-accepted a lot of students, and many have delayed because of visa issues. For anybody who's an international student would fully understand this. Visa issues, getting funding in place happened relatively quickly, but we had a really, really high interest in both of these programs, and we're not at all concerned, I think, going forward about whether we'll be able to fill seats. So keep your eyes and ears open for these programs, and if you have any questions or comments for me or my colleague, I would, I guess, now open the floor to that. Thank you very much.
We do have time for some questions, and I would invite from the floor, or Kelly, maybe if there's any in the chat, you could just wave and we'll listen to them from the chat as well. But any questions from the hearty souls here assembled? Raising your elbow, is that a question or? Yeah, go ahead. Oh, hang on, let me give you the mic. Since we have people online, we don't want to leave them out of the conversation, so please use the mic.
Thank you. I have a question about co-op. These programs, especially software engineering, need co-ops. Why does this program have no co-op option for students?
So as a matter of fact, it will have a co-op option. We didn't present it because that was a relatively new development. I think at the time we were partially concerned about the impact on the undergraduate programs, but we will be offering co-ops for, I think, both of the programs. Yeah, both of the programs will formally have co-ops, just they haven't started yet. We have to work out some of the administrative side of things, but they definitely will. And industry is ripe to support that as well, apparently.
Okay, so in near future, students can access this kind of co-op program. Okay.
That's correct, and I'm not sure if the mic was on. So for anybody online, it wasn't very loud for me. I could hear you fine, but just to repeat the question was about whether the programs would have a co-op associated with them, and so the answer is yes, and they will be coming hopefully very soon. I think that Dr. Peters, do you know? No. Okay. Okay. Great question, though. Thank you.
Thank you.
Should take. Just check your screen.
Okay. So I have two questions. One follow-up from the co-op is that with the addition of the co-op, would it be extra semesters, for example, from 4 semester long, it would be like a 6th semester?
Yeah, that's right. So there would be an impact, but because of the way the electives work within the program, students may have the option of, for example, taking extra electives outside of the planned structure of the program to be able to still try to complete it within a similar time frame. Does that make sense?
Yeah, yeah.
So instead of 3 courses per term, you might be able to take 4 courses in 2 terms and then do a co-op placement. But again, those are the details that we still have to work out within how the program would flow.
Mm-hmm. Okay. And for my second question, I was wondering, what is the main difference if a student goes to Master of Science Computer Science course based, has electives from like AIs and engineering, and that a student, and also like a student that goes to Master of AI.
So there are some courses that are exclusive for the Master of AI, and students in this program will have preference seat, which means that if there are some space available in those courses, we might open it to other programs like the Master of Computer Science, but they are not guaranteed. So the seats in these courses for AI program will be preferential for the students in the MY program, right? And the other is that they will have the capstone. So there is this course that is the capstone in AI, which is only for, we are not going to accept any other students in this course, which is only for students in the AI program. So that course is where they are going to get the hands-on in developing an AI application or AI system, and that will be exclusively for the AI students.
Thank you.
Welcome.
I'm really interested to hear about the approach of the program or the center's approach to ethical thinking and ethical education, because there's so much stuff going on in terms of organizations like All Tech is Human and the Center for Humane Technology. And here in Canada, I've got the Engineering Change Lab doing things with the Technological Stewardship Practice Program. And I'm really curious how, particularly if there's a choose your own adventure component to it, has there been a lot of thought about how to weave that kind of ethical thinking all the way through, or would it be just in one course? Or just maybe you can talk a little bit more about how do you prepare people who are not just industry ready, but who are actually prepared to guide it in some good, responsible directions?
So at this moment, is some of the ethics questions are being covered in the courses. So we have the AI 6001, and part of it is like ethical issues in AI. So we cover it as part of the course. And in other courses, like the one that is Introduction to Machine Learning, there are some sections that are covering kind of ethics or what happens when this goes wrong, right? So we are trying to make students aware. We have to talk about how we are going to integrate these ethical issues with the Center for AI, maybe with some partnerships. Other ideas will be that in the capstone project that the students have to do, like they also have to study and discuss ethical implications of whatever they are doing, right? Like, I think that's the best part where they have to apply this knowledge or this awareness. Like, okay, so you are having to develop this system. Now think about what can go wrong and what are the ethical implications of the system that you are developing. So right now, I think there is no a course in ethics of AI, which might be something that we could discuss and maybe have it as an elective, but it's kind of integrating in some parts of other courses, and definitely something that we have to talk about how we can have it as part of the Center of AI. Maybe some initiatives, maybe some kind of extra curricular activities or projects, but also in the capstone should be there. Like in the capstone project, the students have to talk about and think about and discuss about the ethical implications of what they are doing.
Other questions? Online listeners didn't have any questions? Well, if there's no more questions, we do have time for some chat, and we have a fairly intimate group. So at least those of us who are here in person get to have some one-on-one conversations, if you like. I'd like you to help me thank our speakers again. And I also want to send out, before we do that, but my thanks also to Kelly Foss and Paul Martin for their support tonight in running the show. Kelly's done a lot of work to put it all together, and Paul has run all the tech for us here tonight. Thank you very much for that. So join me once again. And with that, you can join us in the lobby. I believe we have some refreshments, and probably way more refreshments than this small group needs. So we'll go and enjoy some of those, and we can have some smaller conversations. And for those of you online, thank you for joining, and I hope you'll find something to eat in your kitchen.